All right, so we're in week 6 of MAT 205, whether you're in the online live or just the online course. We're going to have the same topics to tackle. Okay, so let's see if I can get this a little bit better. There we go. So we have lots of topics. We've got classifying samples, finding a percentage of a total amount in a SOPL graph. We have computations from pie charts. I'm not going to go through the whole list here, but you can see that it is an aggressive list. So it's probably going to take a few videos to get through these topics, but we will get through it. All right, so we're going to start off with what is the difference between a population versus a sample? So a population is the entire group of individuals that you wish to draw a conclusion about, or an inference, sometimes they'll say. And a sample is the group of people from which you will be collecting data. So you're going to pull your sample. Your sample is going to come from your population. So they're going to pick different people randomly, hopefully. Just grab them right on out and bring them over for the sample. So they're not gonna talk to everybody in the population. They're just gonna pull a little sample out. So why do we use samples instead of using populations? Well, samples are used to make inferences about populations. Remember, those are conclusions. Put that down on here, make a conclusion about a population. Samples right here are easier to collect because they are practical, cost-effective, convenient, and manageable. It would be very expensive for a statistician to try to survey everybody in a population. It'd be very time-consuming, cost a lot of money. So it's not very practical, which is why statisticians and other people collecting data usually try to grab a nice random sample from the population. Okay, so I have a couple examples here of collecting data from a population by grabbing a sample. The first population might be all Wilmington University students. So think about that universe of all Wilmington University students attending classes everywhere, all the campuses. And since it would be too costly and time consuming to sample everybody that's attending Wilmington, maybe as a nice little sample, they go in and grab 15 randomly selected students, maybe from different math classes in the fall of 2024. And that's how they grab their little random sample. Or a population could be all employees working for Amazon, right? So you got all the people out there working for Amazon. And maybe it's too, expensive and time consuming to talk to everybody working at Amazon. So maybe they grab 75 people, picked randomly, maybe from each state where maybe Amazon is operating. So you might see them grab a little sample from there. Okay, in this class, you are going to be responsible for 5 different types of sampling, and you are going to be given scenarios, and you're going to have to figure out what type of sampling is happening. So let's go through the 5 big ones. We have random sampling. Each element in the population, or each person in the population, has an equal chance of being selected. With random sampling, usually a random number generator or a computer using a random number generator is used. I just put a special note here. Random sampling is considered the gold star of sampling. It's the best technique. It's hard to do, but it is the best technique out there. The next type is called systematic. Systematic is where you have a list of elements that is counted off. That is every kth element is selected. So what we're trying to say here is maybe you might have every 10,000th Twinkie that comes off of a conveyor belt is sampled. And that's called systematic sampling. We have stratified. All right, so stratified is very similar to cluster. A lot of times these get confused or confusing between the two. So I'm going to try to help you with that. So stratified divides the population into different strata, usually by some characteristic. Then a sample is taken from each of the strata using either random, systematic, or convenient sampling. So think about stratified is they're taking the population, they're dividing them up into little stratas by some sort of characteristic. Then They have all of these people divided up by some characteristic, then they go in and take a sample from each of the strata. Now, cluster looks a little different. You still are going to be coming in and dividing your population, but this time into groups or clusters. Usually they divide them up geographically. So that's a little difference. So stratified is dividing people up into some characteristic that they share. Cluster is usually dividing up people or whatever they are sampling into little clusters that are geographically related. Then random clusters are selected and each element in the selected cluster is sampled. So there's just some small nuances between these. The last one is convenient sampling. This is where selections are easily accessible. I just put on here, it's the worst technique to use as it produces non-random samples. All right, so keep these close by and we're gonna go to the next slide and take a look at some examples. Okay, I want you to take a look at these 5 scenarios, and then I want you to determine which one of these 5 different types of sampling could be happening. So pause the video and see what you think. Okay, so if you're back, we have situation 1. Hank asked customers leaving Wawa to answer his survey questions. Okay, if you were thinking about which one of these types of sampling this might be, this is convenience sampling. Okay, so I'm gonna write that down here. It's convenience. It's definitely convenient for Hank, right? People are easily accessible, just coming in and out of Wawa. Easily accessible. Okay, so that's one of the characteristics of convenience, is that selections are easily accessible. So that's convenience sampling. Okay. The organizers of a conference assign each attendee a different number. Then they use a random number generator to pick 90 numbers. And the organizers then survey the attendees assigned to those numbers. Okay, there's some keywords here. They used random number generator. Okay, so every attendee walks in, gets assigned a number, and then they probably use a computer program to just randomly select 90 numbers, and then they call the people whose numbers they are attached to. So this one, hopefully you were thinking about, is random sampling. It's random sampling because each attendee has an equal shot of getting selected, an equal chance. An equal chance of getting selected for the survey or whatever it is that they're wanting to talk with these people about. All right, next up, counselors at the University of Delaware form 7 groups of students, 7 groups of students based on the number of classes the students are taking. Then the counselor selects 8 students at random from each of these groups that they have created. So you're probably thinking stratified or clustered. If you went with stratified, you would be right. Let's talk about why. So stratified divides population into strata, usually by some characteristic. The characteristic that they used to divide these groups of students was they shared the number of classes the students are taking. So that's the first piece, is that they divide up the population by some sort of characteristic. The second part is then they take a sample from each of the strata, okay? So then the counselor selected 8 students at random from each group. So that makes that stratified sampling. So we can put down here that they shared a common characteristic. And also, besides sharing the common characteristic, a sample was taken from each of those groups. Okay. An analyst forms groups of 13 customers based on cities the customers live in. Then she selects all of the customers in 6 randomly chosen groups. Okay, if you were thinking cluster, you are all over this. Yes, this is cluster sampling. Okay, it is cluster sampling for a couple different reasons. If we go back to our cheater sheet here, cluster sampling usually divides populations into groups or clusters, usually geographically. So they divided by city, okay, which is geographical. That was our first hint. And then they select all of the customers. So if you notice with cluster, random clusters are selected in each element or all people in the selected cluster is sampled. So they divided them up by city, geographical, and they surveyed or selected all customers in the second group or in the chosen groups. All right, in a population of 10,000 people living in Alaska, and this is just made up. I don't know how many people are living in Alaska right now. A statistician selects every 100th person for sampling. Okay, 100th right here. Okay, it's systematic sampling. It's counted off sampling. So this is systematic. Okay. Okay, so hopefully that is helping you kind of get introduced to different types of sampling. And we're going to keep moving. Okay, we're moving on to finding a percentage of a total amount in a circle graph. So here's our circle graph. You might not be able to read these. This is 13% of fish, 23% dog, 25% bird, 22% cat, 9% snake, and 8% hamster. So I'll just make those a little bigger. Okay, the citizens of Dover, Delaware were asked their favorite type of pet. The circle graph shows how the citizens answered. If 120,000 citizens answer the question, how many chose dog as their favorite type of pet if there's 120,000 citizens in the city of Dover? And what would 23% be? All right, so we're going to take 120,000. We're going to be using that number. We can say of the citizens who answered or who responded, comma, 23% chose dog. So they're dog people. Okay. To find the number of citizens who said, I am a dog person, chose dog. We want to be a dog people at my house, but I think we're more cat. We tried to foster some dogs, did not work. So I think by default, we are now cat people. So to find the number of citizens who chose dog, you're going to multiply 23% by 120,000. So the first thing you're going to do is take that percentage. So 23%. You're going to turn that into, you want to convert to a decimal. So to do that, you divide by 100 and you get 0.23. Okay, so you're going to take in your calculator 120,000 times 0.23, which is almost a quarter, right? Almost a quarter of this whole thing, 23%, a little less than 25%. So what's basically a quarter of 120,000? So we're going to use our calculator to answer this. Okay, so 120,000 times 0.23 is 27,600 people chose dog. 27,600. And let's see if that kind of makes sense. Let's use some critical thinking skills. If 23% is almost 25% or a quarter, and you take 120,000 people and you divide it up into 4 quarters, you're looking at 30,000 people. Well, we're a little under 30,000 because 23% of course is less than 25%. Okay, so 27,600 people, 600 citizens chose dog. So if they ask you any other pet, like let's just say they said of the 120,000 citizens, 8% chose hamster, how many of the people would be choosing hamster? You could just simply go 120,000 times 0.08. That would be hamster. Okay, you could do that for snake. Oopsie, you probably can't see that. 120,000 times 0.09 if you're interested in finding out how many people said snake is their favorite pet. All right, hopefully this is making some sense. Let's move on to the next problem. All right, the pie chart shows how total income for a certain family is spent. If the amount budgeted for housing, food, and savings combined is $68,150, what is the total family income? Okay, so here's the issue. We only know that this $68,150 is just covering these 3 pieces of the pie. That is not the total family income. So that's going to be the question mark. That's going to be our X or our T for total family income. Okay, what do we know? We know that we can add savings, housing, and food. Savings plus housing plus food is going to equal 6% plus 25% because they're combined, plus 16%. If we add 6%, 25%, and 16%, we're going to get 47%, which kind of makes sense because half of the pie, let's just shoot like that. This would be half of it, right? 47% is a little less than 50%, so that kind of makes sense. So we're probably on the right track with that. We also know the combined income is $68,150. Total family income, we'll call that T, we don't know. Okay, here's what we do know. We know that 47%, let's convert that to a decimal. Let's divide that by 100. Go 0.47. So 0.47, we know that, times total family income, which we don't know, that's the unknown, has to equal this combined $68,150. Okay, so let's take a look at what the setup is here. We know that 47% right here times the total family income would be equal to $68,150. This is what we don't know. We don't know what this is. Back when you were learning this, maybe in an earlier math class, sometimes they would do it like this. They would put a box. And then the question is, what's the box? And then if they eventually get rid of the box and just put a letter here. So if you recall from algebra, when you have 2 items multiplying to each other, right, which these are, and you want to figure out what, let's just say this one is, which is going to be our T. If things are multiplying, you know you can undo that by doing the opposite of multiplication, which is division. And because we're working with algebra, algebra is very fair. Life isn't fair, but algebra is. So if you divide one side of this equation by 0.47, you got to do it to the other side. And what's cool about dividing 0.47 by the 0.47 is it cancels itself out, leaving us basically just T is equal to, then we're going to have to take our calculator and figure out what is, let's do that, 68,150, oopsie, divided by 0.47. All right, so the total family income has to be 145,000. So T equals 145,000. And you could check that if you wanted. You could go backwards and say 145,000 times 0.47, right? 145,000 times 0.47. It's going to bring us back to the 68,150. Okay, so they're asking us for total family income, and that is $145,000. Total family working together income. Okay, So this might take a few practices when you're getting into ALEKS, but I know you can get this. Okay, we're gonna move on to constructing frequency distributions for non-group data. A doctor's office has 4 doctors. This morning, 24 patients visited the office. Each patient saw one of the 4 doctors. So the key is F is Dr. Foster, M is Dr. Mitchell, P is Dr. Patel, T is Dr. Tran. Okay, fill out the frequency distribution for the data below. This looks like one of those eye tests you take when you go to the eye doctor. Okay, so let's see how we're gonna go at this. So there's many ways to skin this cat, and everyone's gonna skin it a little differently, but for me, I would probably start off with just identifying who's going to see Dr. Foster, so I would count up all my Fs or highlight those. So I see 8 people seeing Dr. Foster. That's how many times or how frequently those patients came up. Let's look at Dr. Mitchell, starting with an M. I see 7 people came to see Dr. Mitchell. Okay. Then of course we have Dr. Patel. That's P. 1, 2, 3, 4. All right, 4 people coming to see Dr. Patel. And then the last few people, 1 patients, 1, 2, 3, 4, 5, are seeing Dr. Tran. Okay, so however you went at that, totally fine. I use colors to kind of help me, but if you don't have highlighters, maybe cross through as you go. And you could make a tally, like if you wanted to, and you were counting up your Fs for Dr. Foster, you could say 1, 2, 3, 4, 5, 6, 7, 8. And then Dr. Mitchell, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4 for Dr. Patel. 1, 2, 3, 4, 5. These are ticker marks for Dr. Tran. Ticker marks. So sometimes when you are looking at data and you're asked to fill out a frequency distribution chart, that's what this is. Sometimes people use ticker marks and then they add up their tickers and they're able to get the frequency. Alrighty then. That didn't seem too horrible. Something else that you could do is also add this up to make sure that you do have 24 patients. So we know 8 and 7 is 15, plus 5 is 20, plus 4. So we do get 24 people. If I was taking a test, I would probably stop for a minute, pause, and just make sure that that came out right. Okay, we're still working with the same doctors. A doctor's office has 4 doctors. This morning, 24 patients visited, and they saw each of these 4 doctors. These doctors are affiliated with 4 major medical groups. So what we're doing is we're still working on constructing a frequency distribution or analyzing a frequency distribution chart for non-group data. So these doctors are affiliated with 4 major medical groups. Not every doctor is affiliated with every group. The table shows the groups and the doctors affiliated with them. And here's the question that they popped to us. How many patients went to see a doctor affiliated with the CityMed medical group? Okay, so we're gonna be looking right in here, CityMed, all right. So that would be F, Dr. Foster. And P would be Dr. Patel. So we're gonna have to go back to our previous data. And let me go grab that so we can figure out how many patients went to see them. And they are affiliated with the CityMed medical group. Okay, Dr. Foster had 8 and Dr. Patel had 4. So 8 plus 4 is gonna leave us with 12 patients. Okay, not too shabby. Hopefully that makes sense, and hopefully you're pausing the video as you're seeing each of these problems pop up. And working on it yourself and then coming back to check to see how you did. Okay, so we've moved on to constructing frequency distributions for what's called group data. So we were looking at ungrouped, but now we're going to look at grouped. 9 cyclists were each asked the distance in miles they biked each week. So I'm assuming these are their responses. So these are 9 cyclists were telling them how many miles that they biked every week or last week. So here's the 9 responses. Complete the group frequency distribution for the data. In the distribution, the frequency of a class is the number of distances in that class. Note that we're using a class width of 6. I'm going to highlight this because you're going to be asked to determine class width. I'm going to show you how to do that. Okay. So let's look at the width. This class right here, I'm just going to kind of draw over here. This class width, they say that it's equal to 6. And here's how you can do it with your fingers. So you start with, this might be silly, but it's how I do it. All right, so to get from 2 to 7, I've started 2, 3, 4, 5, 6, 7. So my width has 6 fingers, okay? Same for 8 to 13. 8, 9, 10, 11, 12, 13. Class width of 6. 14 to 19. Start with 14, 15, 16, 17, 18, 19. I've still got 6. So that's how you can determine the class width. You always start with the lower one. That's the first finger you're going to throw out, and then you're going to go all the way up to the higher one. You can do this mathematically, but for me, the finger method is all, that sounds terrible. We're giving 6 fingers, okay, for the class width. So that's how wide this interval is. Okay, so that's what they're really saying is how wide of an interval. Okay, so for this, we might use some ticker marks. Let's see here. So you're going to start to look at this person here said they biked 9 miles. So 9 is going to fall in between 8 and 13. So I'm going to give this a little ticker mark like there. Okay, so I'm going to cross that off. 3 would fall between 2 and 7. It's in that class width. 4 is also between 2 and 7 miles. 12 is between 8 and 13. 11 is between 8 and 13. 10 is between 8 and 13. 15 is definitely going to go in this interval, this right here. 3 is going to pop back down to here. And 10 is between 8 and 13. So what we have here is 3, 5, and 1. If we add those together, 5, 6, 7, 8, 9, we have our 9 cyclists. Okay. And what we did is we just grouped their distances into these different intervals. So 3 people said that they biked between 2 and 7 miles that last week. 5 people said they biked between 8 and 13 miles. And 1 person said that they biked between 14 and 19 miles. That is a lot of biking. All right, we're going to start looking at a histogram. A histogram is different from a bar chart because a histogram, the bars actually touch each other. Okay. So you can see each of these bars, they touch each other. It's different from a bar graph. A bar graph you might see it looks like this. And what's the difference between a bar graph and a histogram is the bars don't touch. This is a bar graph. So sometimes you might be looking at data like in the news and they're like, hey, check out this histogram, and they show you a bar graph. Or they might say, check out this bar graph, and they're showing you a histogram. So you will know the difference. Bar graph, the bars don't touch. The bars do not touch for it to be officially a bar graph. So if you're ever on Jeopardy one day, you'll know the difference between the two. What is histogram for $3,000? All right. Kimala is a marine biologist studying the breeding habits of an exotic species of sea turtles. Last year, she observed the number of pregnant mother turtles at each beach on an isolated island in the Pacific. The histogram below summarizes the data. Use the histogram to answer the questions. Okay, so the questions are down here kind of in the corner. What's the class width? How many beaches had 7 or fewer pregnant turtles? And one class is the most frequent class. How many beaches are in this class? Okay, let's take a look at this. Let's break this apart. So on our x-axis, we have the number of pregnant turtles, and notice that they are lumped into these categories, these intervals. Okay. This is the number of pregnant turtles. Whee! On the y-axis is the number of beaches that these turtles go to. So we got 0 all the way up to 10. Okay, so what you're gonna do is we're gonna start off with what's the class width. Okay, I want you to use your fingers, right? So this says 2 to 4. So you're gonna go 2, 3, 4. That's a class width of 3. Same with this. 5, 6, 7. 8, 9, 10. And 11, 12, 13. It might be dumb to do it this way, but it's never failed me. So our class width is 3, okay? Okay, how many beaches had 7 or fewer pregnant turtles? Okay, so 7 or fewer pregnant turtles. Take a look at this. And let me see if I can write these out a little bit better for you. Okay, so we're asked how many beaches had 7 or fewer pregnant turtles. So it's not going to be 8 to 10, and it's not going to be 11 to 13. So 7 or fewer would be all of these right here, pregnant turtles in here and here. So you're going to look at the height of the bar, and you're going to come over and kind of see what it corresponds to as far as the number of beaches. So if you look over here, we're right at 2. And if you come over here and kind of use your eyesight, sometimes I use like my debit card or something to kind of use it as a ruler. I see 4. So 4 plus 2 is going to give us 6 beaches had 7 or fewer pregnant turtles. Okay, last question. One class is the most frequent. How many beaches are in this class? Okay, we're going to look for the tallest bar. So this tallest bar is right here. If you kind of eyeball this, all right, this is 7. This has 5 in here. Okay, one class. So we have 4 classes here. These different intervals are each classes. One class is the most frequent. So that's going to be the one with the tallest bar. How many beaches are in that class? And the answer is 7. Okay, let's keep it moving. All right, we're interpreting a stem and leaf display. The stem and leaf display below gives fuel efficiencies in miles per gallon for a sample of 17 new cars. Use this display to answer the questions that follow. Okay, so let's take a look at the stem and leaf. First of all, right here, this is your stem. Let's see if I can spell that right. That's your stem column, and these right here are your leaves. Okay, they always give you a key. You should always have a key when you're looking at a stem and leaf display. So 1/0, which is right here, means a fuel efficiency of 10. So that is 10, if we look at this, 10 and 14. So this would be 22, 25, and 26. And you don't have to do this. I'm just kind of talking you through this if you've never seen this before. Like this would be 50, 50, 52, 54. 50, 50, 52, 54. And these are MPGs, miles per gallon. MPGs. Okay, question A. What is the lowest fuel efficiency in the sample overall? Okay, well, it's probably going to be this right here, this 10. That is the lowest fuel efficiency. Notice it goes all the way up to 54 miles per gallon. So 10. What's the highest fuel efficiency in the 30s? Okay, let's look at 30. So 33, 36, 37, 37, 39. And how many cars in the sample have fuel efficiencies in the 50s? Okay, we have 50, 50, 52, 54. So that would be 4. So that's how you interpret a stem and leaf. And now we're going to create one ourselves. Notice the stems start with 1, 2, 3, 4, 5, and then the leaves just sort of are stacked horizontally. All right, this will be the last problem we do in this particular video. A lot of stuff happening this week. Create a stem and leaf display of the following fuel efficiencies of 15 new cars. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, we're gonna make our stem and our leaf. Thankfully, they put this in order, 17 all the way up to 56. So that's kind of nice. So we can go with 1, and we have a 7, so that's 17. We have a 2 and an 8. And then 2 29s. Then we have a 30, another 30, a 31, a 33, a 34. That's it for the 30s. Now we're going to start with the 4. So 42, 47, 48, 49, and then we're going to get to 50s. So 52 and 56. If you count each of your leaves, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That should match. And you always want to make a key. So we could say 1/7 equals 17 miles per gallon. So we're going to make ourselves a key. That's always not a keg. What am I thinking? Oh, you want to make yourself a little key. This is for anybody that might be looking over your shoulder. Okay, I'll see you in the next video.